All right, so we're going to take a look at these. On the first one, sorry about that again. First one, minus minus plus plus. That does not alternate. So it's not an alternating series. So there's no test currently that works with the direct comparison, limit comparison, integral test, alternating series. You can't do any of those. So that's why I teach you what we're learning today. So let's look at the absolute value of that whole thing. Okay? This whole -1 to the exponent thing over 3 to the n, I don't care what in the world that exponent thing is. When I do the absolute value, I am looking at n equals 1 to infinity of 1 over 3n, which some of you might like to rewrite it as 1 over 3 to the n. And from that, r is less than 1, so by the geometric series, it converges. So this thing converges in jail, so it's definitely going to converge out of jail. So this is absolutely convergent, AC. Okay, let's look at this one. Okay, so this one here. Okay, this one here, it alternates. So I can do an alternating series test on it. And in the alternating series test, give me one sec. So with the alternating series thing, the terms go to 0. The a to n plus 1 guy is always less than a to n guy, so this guy converges. He's converging out of jail, so I know he's convergent. Now I'm curious about locking him up in jail, and I want to see what happens to this piece in jail, if he's still my friend or if he's not. Okay? So when I put him in jail, we are really looking at ln of n plus 1. Okay? Now, on this thing, I want you to first think for a moment of ln of n versus n. When you graph that, there's the ln function, and there's the n function. Okay, I know it's n plus 1. All that thing would do is it would shift that over 1. Now that's the ln of n plus 1. It just shifts it to the right or to the left. The biggest part, though, is I want you to take a look at that and realize who's more powerful. Who's blowing up quicker, n or ln? And just from the picture, n is going to be bigger than the ln of n plus 1. So then you could say 1 over n versus 1 over ln of n plus 1. If the n is bigger, that makes it smaller as the fraction. Okay? And I'm doing a direct comparison here, direct comparison test. This guy diverges. So let's look at the picture here. He's the smaller version, and he diverges. Let me color coordinate this. Here's the 1 over n guy, and he diverges. So then this 1 over ln dude, who's bigger than him, has to what? Also diverge. So in this case, for this problem, the regular dude converged, the absolute value dude diverged. So put those together, that means this problem was conditionally convergent. Meaning, again, you're my friend only if you're out of jail. You're not my friend if I put you in jail. Okay. Lastly, 4 extra problems here that we're going to take a look at. These are just type of questions where you see the -1 to the n plus 1, -1 to the n, so they're alternating. And you need to make a decision on, you got 3 options. I want to know if these things are divergent, absolute convergent, or conditionally convergent. Those are your three options. If it's divergent, boom, diverge, done. If it's convergent, I need you to determine if it's AC or CC. 4 problems. I'd hit pause on the video, and then I would try them out with your partners or whatnot. Then when you're ready, resume the video, and then you can see how well you did, and we'll go from there. Okay, I'm going to do a little bit of this out of order. I'm going to get through my favorite type first. Right here, the last term would be, you're looking at 2n over n, basically, which is 2. So you're looking at plus 2, minus 2, plus 2s, all of that stuff. All you can say from that is the last term is not 0, so this is a diverge by the divergence test. I'm going to look at one more that I like. Here, the limit as n goes to infinity of inverse tangent of n is pi over 2. That is not 0, so by the divergence test, this diverges. I love those guys. Now I'll look at some that actually work. Okay. First thing here, alternating series. Guys go to 0. The next guy is less than the current guy, so he converges. And since he converges, you need to decide if he absolutely converges or only conditionally converges. To do that, we are going to explore the absolute value piece of the -1 to the exponent of n square root of n. That really gets me to 1 over n to the 3/2. 3/2 is greater than 1, so by p series, this guy converges. So when you're out of jail, that's the blue part, you converge. When you're in jail, you still converge. So for this, you are a winner. You are absolutely, my friend, you are absolutely convergent. Okay? So now we got one more here. This guy, you might want to write it, and you might see it better, as -1 to n over e to the n squared. Okay? Definitely alternating series. The things go to 0. One guy is smaller than the previous guy, so he converges. So since he converges, I'm going to pull down here. I'm going to take a look at him in jail. So I'm going to throw this guy in jail, and I'm going to see what happens in jail. So in jail, I got 1 over e to the n squared. Okay. Now I got to think about this one a little bit. This is not directly a p series because it's not just like e to the n. It's not just n to an exponent. So I got to think here, and I'm going to look and go, okay, I want to compare this guy to 1 over e to the n. Okay? I want you to think about that for a second. Now in doing that, which guy is bigger on bottom? E to the n squared or e to the n? Which bottom is bigger? The black one. The e to the n squared is bigger on bottom, which means he is smaller as an overall. So this blue one I want to look at is 1 over e to the n. That is geometric. R is less than 1, so he converges. So picture time here. Blue guy converged. The black one is underneath it. So he also converges by the direct comparison test. So for that problem, it converged without the absolute values, and it converged with the absolute values. So he is also absolutely convergent. Just remember, I'm now extracting it used to be you diverge or you converge. Now you either diverge or you converge, and if you converge, you can absolutely converge, or conditionally converge. The only times you would really look at the absolute converge versus conditional converge is if you have alternating series or random alternating things. So like plus, plus, minus, minus, plus, plus, minus, minus, minus. Everything up through Wednesday, so Monday's lecture and Tuesday's lecture, there is no negatives ever. So putting an absolute value on it or not is the exact same thing. All of those, when they converge, they absolutely converge because you never had negatives to take away. It's only been since Wednesday where everything alternated, or today where they kind of have random patterns, plus, plus, minus, minus, that sort of thing, that you can really dive into the difference between absolutely converging or conditionally converging. Okay, a little bit short of lecture. There's your homework. Again, 2 different sets. The lecture was, let's see, about 20 minutes and about 11 minutes. 30 minutes plus your warm-ups and those extra problems. So you might still have 30, 40 minutes to try this stuff out in class. So maybe no homework for the weekend, which would be sweet. Thanks, guys. See ya.